Welcome back, my subscribers, and if you're not a subscriber, please subscribe right now. So today we're going to be solving a question from Levi Mwanawasa Medical University on circular motion tutorial sheet 4 question 2. It was requested. So now you can send requested questions to David. This is an email, David C Banda 237 at gmail.com, or you can send or you can send the question on WhatsApp to 0978957975, and I can be able to respond to it and make a video like this one. So now question 2 reads: a floppy disk in a computer rotates from rest up to an angular speed of 331.4 rads per second in the time of 0.892 seconds. So now we go right ahead to our questions. I'll be saying the question, then I answer it. So question A says, what is the angular acceleration of the disk assuming the angular acceleration is uniform? So now angular acceleration cannot be uniform, but then we're being told to assume it's uniform. Thus we can use the equation which has the uniform acceleration. So we have the equation in linear motion. The equation is A, acceleration is equal to velocity minus initial velocity over the time. But then when we come to circular motion, we're going to have angular acceleration is equal to angular velocity minus angular velocity initial over the time. So this actually comes from that. So now we're being told to say that's the angular speed, and it comes from rest. So now the velocity initial we know is 0, and then this will be 331.4 rads per second over the time, which is 0.892. And remember, we've chosen to ignore this because it's actually 0. So 31.4 divided by 0.892, that will be 35.2. And then we'll choose to use 3 significant figures because those are significant figures in the question. We can, that's in rads per second squared. Those are the units. And then question B says, how many rotations does the disk make while coming up to speed? So now this rotates coming to that speed, starts rotating from 0 and it comes to that speed. Now how many revolutions does it take for it to rotate? So if this is a disk, it's at rest, so it starts going, and then it assumes it acquires the angular speed of that much in that much of seconds. So now how many the rotations does it take? So what we're going to find here, we're going to find the distance. So we're going to find the distance which you to travel. So let's say the disk starts the point, let's say the starting point is here, then it travels like that. So now this one will be a half revolution. So then when it goes like that, that will be a full revolution, and then it keeps going until it comes to a speed. That number of revolutions we don't know, but then we're going to find by finding the distance. So we're going to find the distance, and then the distance in circular motion rather is the angle theta. So we're going to find the angle theta. It's defined by the angle theta. So if it's here, our theta will be there. If it's there, our theta will be this angle theta. That will be the distance. We don't actually count the distance in meters. So now when we find that distance, we're going to divide it. We're going to change that distance into revolutions. So if let's say the distance was here, that would be half revolution. So now we know that 1 revolution is equal to 2 pi rads. So we're going to find the rads, and then we're going to change them into revolutions since we know this conversion. So now using that explanation, we can start. So we have various from the kinematic equation. We are going to come from this one, which says y is equal to y naught plus v naught t plus gt. squared. Of course, there are many. 1 over 2. This is a acceleration, and that's when we are dealing with free fall. That's when it becomes gravity. So this is the equation that we can use because it has the distance. These are actually the distances. It has the initial velocity, which we already know. It has the gravity, which we already know. Then it has the time, of course, which we have. So we can now change this into the equation for angular acceleration. And remember, if you can actually know this one, you can start from there. But basically, when I was doing this, I used to find it hard to actually come up with the equations. So to come from the kinematics equations and then find the equations in angular acceleration, because they don't actually change. So now when this one goes inside, we have y minus y naught being equal to v naught plus 1 over 2 gt squared. So now this one is just a change in y. That's this y final minus y initial v naught t plus 1 over 2. This is this is acceleration. I'm used to free fall, sorry. So now this y changes to the theta, the angle theta. Then this velocity changes to the angular velocity initial, the time plus 1 over 2. This acceleration changes to the angular acceleration, and we have our time. So now when you look at this question, the initial velocity is 0, just as I said, it started from rest. So you can cancel out this one. We have our theta being equal to 1 over 2 at squared. So this is our that's our equation for the theta. So now we're going to find our theta being equal to 1 over 2. The angular acceleration we've already found, 35.2. The time is 0.892 seconds squared. So our theta will now be equal to 35.2 times 0.892 0.892 squared. All of this is divided by 2, so I'm going to have this as 14.0 rads. And as usual, we take to the significant figures that we've been given in the question. The question has 3 significant figures, so our answers will follow suit. So now before we go to C, so this is our theta, but then we are being told to find the number of rotations here. So now we can use the conversion, this conversion. So one revolution is equal to 2 pi rads. Thus 14 rads will be equal to will be 14. Oh, this is the 14 rads will be here. So the 14 rads will be there, and then we'll be finding the number of revolutions, which you can write as our x. So to write this, is 1 revolution is equal to 2 pi rads over x over 14 rads. So now when we cross multiply this, we're going to have our x. This one will multiply with that, so we're going to have our x. This will be 2 pi. Of course, 2 pi x is equal to 14 rads. So that's when you divide both sides by 2 pi over 2 pi. Our x will be equal to 14 divided by 2 pi. We find the answer being equal to 2.23 revolutions. So now one other way you can actually find this one is by using the conversion factor. So you can say 14 rads multiplied by one revolution is equal to 2 pi rads, because we want the rads to cancel, the rads will cancel. So now the 14 will remain to divide with the 2 pi, and 14 divided by 2 pi we already found to be 2.23 revolutions. So now we can go on and find C. C says if the radius of the disk is 4.5 centimeters, find the final linear speed of the microbe radial on the rim of the disk. So now on the rim, so that's at like the end of the disk. So now for us to find the linear speed, we are going to use the equation which we already know. The velocity, the linear velocity is equal to the radius times the angular velocity. Now since it's at the rim, it's at full radius, so now we can use the radius of the disk. V is equal to radius of the disk is 4.5 centimeters, but then we can convert that as 4.45 times 10 to the power negative 2. Now it's in meters. Then the angular speed we've already been given is 31.4. So now we can multiply this 31.4 by 4.45. This is times 10 to the power negative 2. That's 1.3973 meters per second. But then when you take it to three significant figures, this 9 will be changed by a 7, then it will be a 10, then it will change the 4, so it will be 1.40 meters per second. Then we are done here. We can go to D. D says what is the tangential acceleration of the microbe at this time. So now we know that the tangential acceleration is equal to the radius times the angular acceleration. So now we can say acceleration tangential is equal to the radius is the same, 4.45. Remember, always take to SI units. Then the angular acceleration we already found is this one, 35.2. So now the acceleration tangential is equal to 4.45 exponent negative 2 times 35.2. We're finding our answer being equal to 1.57 meters per second squared. So that's all for our question. If you have any other questions, it can be on circular motion, any problem in physics, it can be chemistry, it can be math, it can be biology. You can just send the question to this email or this WhatsApp number, and I can be able to work on it and make a video like this one. And remember, subscribe to this YouTube channel. You can like the video and comment what you wanna see in the next video. From me, the Investor Data Boy, it's bye bye.